Hello again, it's Dave Giles here for the next lesson of Cambridge International Education IGCSE Physics, Unit P3 Waves. Today we are looking at diffraction and only describe the process of diffraction today. That is our learning objective. So a quick question, describe what has happened to the waterway, as they pass through the harbour inlet. Now, you can probably guess from the title here being diffracted, but what does that mean? Well, you can see here the waves, they start to come when they come through the inlet here, they start to look a lot more curved. Okay, so that is the basics of diffraction. So diffraction is the spreading of a wave when it travels through a gap or small obstacle. You can also get edge diffraction, where just one edge of a wave is diffracted, but that's the definition that you need at IGCSE. So here we have diffraction demonstration. So I'm using the PhET website. When I've posted a link there, you can use it yourself. And this here is a wave. And you can see that first of all, this here shows amplitude. So you can see the gray trace, that's the trace, sorry. The dark gray trace is the initial amplitude. So before it goes through the inlet. And the lighter gray trace is the amplitude after it goes through the inlet. Now, what I can do is I can make the slit, so the slit here, or the gap, a lot bigger. And you can see that when I make it bigger, if that's small, that is big. You can see now that the amplitude has got a bit smaller. And if I just change the frequency a little bit, say I'll make the frequency higher. So I'll start off with a fairly small slit. Okay, you can see the difference there between the amplitudes. And you can also see by how dark it is. However, now I'm going to make the slit a lot wider. Okay. And again, you can see the difference between the amplitudes. So I shall close this. So this here is the wavelength from the center of one of these to the center of the next. And you may have noticed that the intensity, due to the amplitude, became lower after. So the wavelength does not change. Still got the same wavelength. The frequency does not change. The speed of the wave does not change, but the amplitude of the wave decreases after diffraction. So the amplitude decreases, so therefore the intensity decreases. That's high intensity before, and then low intensity. So water waves are diffracted when they hit the side of an object or pass through a gap. The waves curve when they diffract. Maximum diffraction occurs when the gap is approximately the same size as the wavelength. So you can see here on my screen, now it'll look different depending on what device you're using, but on my screen, the wavelength between these 2 points here looks to be about 1 centimeter. That gap, it's just over 1 centimeter. So we've got maximum diffraction. Whereas here, the wavelength is still about 1 centimeter, but the gap looks to be, without getting my ruler out, to be about 10 centimeters. So there's not as much diffraction going on. The edges are diffracted, but the center is still straight. Okay. So this kind of sums up a bit of what we've done over the last few lessons to describe what happens to the wave as it hits part A. So the wave is just going to be reflected at the same angle it hit the wall at. Describe what happens as the wave reaches part B. So it's a sandbank, so it's going to become more shallow. So when the depth changes, then we get refraction, and it will slow down. And describe what happens to the wave when it reaches part C. This is where we're looking at today's lesson. This is diffraction, spreading out after the gap in a semicircular shape. Describe what happened. The gap at part C was made smaller and then much larger. The gap's at the moment approximately the same size as the wavelength, so at the moment maximum diffraction. Make it much smaller, and the wave will be just reflected. And make it much bigger, and it will be diffracted less. Now, I'll point out I've never seen an IGCSE question where it actually asks you to talk about the fact it's much smaller, it's mainly reflected. So I've never actually seen that at IGCSE yet. So let's have a look at some paper 2 exam questions on diffraction. The diagram shows a water wave passing through a gap in the harbour wall. The wave fronts curve round the wall and reaches a small boat in the harbour. What is the name of the curving effect, and how can the gap be changed so the wave fronts do not reach the boat? So the name of the effect is diffraction, and you would make the gap slightly smaller so it doesn't reach the boat. A water wave in a shallow tank passes through a gap in the barrier. What happens to the speed and what happens to the wavelength of the wave as it passes through the gap? Well, the speed, we say, stays the same. The wavelength also stays the same, so it's therefore D. Next question. In a ripple tank, move that away. In a ripple tank, plain water waves meet a straight barrier with a wide gap in it. Which diagram shows the wave patterns beyond the barrier? So you can see here that the barrier is going to be quite a bit bigger than the wavelength. Okay, so we're going to have a bit of a straight bit in the middle, so that the center of it will be not diffracted. It's the edges which will be diffracted, and the only one showing only the edges diffracted is D. Therefore, it is D. The diagram shows wave fronts of a water wave passing through a gap in a barrier. Which change will increase the diffraction of the wave as it passes through the gap? Now, this is a little bit of a trickier one, so I'll go through it. Increase the amplitude. That's not going to change the amount of diffraction. Increasing the width of the gap. That'll actually decrease the amount of diffraction. Reduce the water depth. That will not affect it. And I'll just change the speed. Reduce the frequency of the waves. Okay, so if you reduce the frequency of the waves, then your wavelength, if you reduce the frequency of the waves, then your wavelength will increase. So therefore, you will get more diffracts. So therefore, the size of the wave will be about the same size as the barrier. So therefore, you will get more diffraction. So this was a bit of a trickier question to end things on for this lesson. That's it for today. The next lesson I will be uploading soon will be lenses. Now, as usual, I'll post a link down below in the description. Thank you very much, everyone, and see you later.